My dear students, in this video, I am going to start a new topic in our 12th standard State Board syllabus, chapter number 6, Applications of Vector Algebra. The concepts of basic vector algebra you have studied in the 11th standard itself. So, basic concepts of vector algebra in your 11th standard you have studied, that is the definition of a vector and the scalar, examples of vector and scalar addition of vectors, and triangular law of vector addition, parallelogram law of vector addition, and the magnitude of a vector and the direction cosines of a vector, and these are the things you have studied in your 11th standard as a basic concept in vector algebra. Now in 12th standard, applications of vector algebra we are going to see in the chapter 6. Vector algebra applications. The first concept is product of two vectors. Product of two vectors. Product of two vectors, say A and B. In that product of two vectors, first we have to define. We are defining first product is dot product or scalar product. First product is product of two vectors. First one, scalar product. Scalar product or dot product of two vectors. Scalar product or dot product of two vectors A and B. See, now you consider OA in the direction of A. OA is vector A. This is the point to origin. And OB, in this direction, the vector B is defined. OA, in the direction of OA, vector A is defined, and in the direction of OB, vector B is defined. And theta is the angle between the two vectors A and B. Theta is the angle between the two vectors A and B. And that theta measured in the counterclockwise sense. Always the angle between the two lines will be measured in the counterclockwise sense. That means anti-clockwise sense, you know. So, the definition, A scalar product of two vectors A dot B. It is denoted as A dot B. Scalar product of two vectors is defined by A dot B equal to modulus of vector A and modulus of vector B and cosine of the angle between the two vectors theta, cos theta. So A dot B by definition, dot product or scalar product of two vectors A dot B is mod of A into modulus of B into cos theta. This is the definition of two vectors, where theta is the angle between the two vectors A and B. See, why it is called scalar product? Modulus of A is a scalar, no, and modulus of B is also a scalar. And cosine of angle theta, suppose theta is 30 degree, cos 30 is root 3 by 2, or theta is 60 degree, cos 60 is 1 by 2, like that. Mod of A is a scalar and mod of B is also a scalar, and cosine of angle theta is also a scalar. Therefore, the entire product becomes a scalar quantity. That's why the dot product of A and B is also called a scalar product. This is A dot B definition. Mod of A, OA, mod of B, distance OB, and cosine of the angle between the vector theta in the counterclockwise sense. This is the definition of the dot product of vectors A and B. See, this theta is measured in the counterclockwise direction, and also theta is the angle between A and B. Theta is the angle. Theta is the angle between the vectors. Angle between the vectors. Theta is the angle between the vectors A and B. Their directions, the vectors' directions, their directions the directions both converge. The directions both converge or diverge. From the point of intersection of two vectors. If theta is the angle between the vectors A and B, their directions both converge or diverge at the point of intersection. That means this is diverging. Theta, both vectors A and B, angle between the vectors A and B, or diverge from O. Converge means this is A and this is B. Converging at the point of intersection. This is angle theta. Both the directions of vector A are diverge or converge at the point of intersection, and that is the angle theta. Okay, this is the definition of the vectors, dot product of the vectors A and B, and we will see the properties of dot product of the vectors. Okay. Now we have defined what is that. A dot B is dot product of two vectors. A dot B equal to modulus of vector A and modulus of vector B and cosine of the angle between vectors A and B. Theta, where theta measured in the counterclockwise direction of the angle between vectors A and B, and theta usually lies between 0 to pi, 180, 0 to 180. Theta lies between 0 to 180. First one, 0 to 180, then 0 to pi. This is the nature of theta. Now I am going to give you properties of scalar product or dot product. Scalar product or dot. Properties of first, scalar product or dot product is commutative. Scalar product or dot product is commutative. Scalar product is commutative. That means A vector dot B vector equal to B vector dot A vector. See, by defining dot product, you should put dot compulsory. Without giving dot, there is no meaningless. You just write AB. If you write AB, it will not imply dot product of A and B. If you put dot only, it is a dot product or scalar product. Okay. So now first property is dot product is commutative. What is that? We will see. What is A dot B? You know A dot B is mod A modulus of B vector into cos theta. This is A dot B. What is B dot A? You know, this is theta, OA is vector A and OB is vector B, and theta is the angle between vectors A and B measured in the counterclockwise direction. O is the point of contact of vectors A and B. A dot B is mod B cos theta. But B dot A is B dot A, it measured in the clockwise direction. B dot A, that means mod of B into modulus of vector A into cos of, the direction is in clockwise direction, therefore theta becomes minus theta. It is in the clockwise direction, B dot A. You know, you rewrite this B into A is A into B, both are same. This is mod A, mod B. B dot B into A is also equal to A into B, therefore I can write it as mod A mod B instead of mod B mod A. Cos of minus theta, you know cos theta. Cos of minus theta is cos theta. Therefore B dot A is also mod A mod B cos theta. It is A dot B. So A dot B equal to B dot A is derived, therefore dot product is commutative. The property is derived. Okay? Next property, dot product is commutative. Okay? Next property, second property, dot product of collinear vectors. You know what is meant by collinear vectors? If the two vectors acting along the same line, that is called collinear vectors. See, this is your A vector and B vector is also acting along the same line. So A and B. Suppose this is A and this is B vector. The B coincides with the vector A, and this is the case. You know this is theta. B coincides with the vector A. If A and B are collinear, theta becomes 0 degree. Theta becomes 0. If dot product of collinear vectors, if the vectors A and B are acting along the same line in the same direction. Collinear means A vector and B vector are acting along the same line. Acting along the same line in the same direction. Acting along the same line in the same direction. In this case, theta is 0. Therefore, A dot B equal to mod of A into modulus of B into cos 0, because theta is 0. You know, mod of A is A and mod of B. Cos 0 is 1. Therefore, A dot B equal to modulus of A is A, modulus of B is B, that's all A, B. Cos 0 is 1. So, A dot B is AB. If A and B are in the same direction, acting on the same line, if the A and B are collinear vectors, then we say that A dot B is AB, it is positive. Suppose A and B are acting along the opposite direction. See, this is your vector A, and this vector B describes 180 degree and acting along the opposite direction. This is your theta. So B acting along the opposite direction of A, and it describes theta is pi, that is 180 degree. So in this case, if A and B are acting along the same line in the opposite direction, and A and B are in the opposite direction, if A vector and B vector are in the opposite direction, acting along in the opposite direction, the same line, it is also the collinear. It is also the, in this case also, by vectors A and B are collinear. If A and B are in the opposite direction, A dot B equal to mod of A into mod of B into cos phi. Mod of A is A, mod of B is B. You know, cos phi is minus 1, therefore this is minus AB. It is negative. So, if A and B are acting in the same direction, A dot B is AB, positive. If A and B are in the opposite direction, dot product AB is minus AB. A dot B is minus AB, which is negative. So, in these both the cases, the vectors A and B are collinear. If A and B are collinear in the same direction, A dot B is AB. If A and B are collinear but in the opposite direction, A dot B is minus AB. That's all about this property. Okay? Next, property 3. Sign of dot product of vectors A and B. The dot product A dot B may be positive, negative or 0. See, first case, if the angle between A and B, that is theta is acute angle, that is theta lies in the first quadrant. Theta is an acute angle. In this case, theta lies in the first quadrant. This is called acute angle, less than 90. It is theta lies in the first quadrant. First quadrant cos theta is positive. Cos theta is positive in the first quadrant, hence A dot B is positive. See, if A dot B is positive, the angle theta is acute. That is the inference we get from this idea. Next, if the angle between theta is obtuse, that is theta lies in the second quadrant, lies between 90 and 180. Theta lies in the second quadrant, that is theta lies between 90 degree and 180 degree. In this case, second quadrant cos theta is negative. Therefore, A dot B is negative. So, A dot B negative, it implies that theta is obtuse. If A dot B is positive, theta is acute. A dot B is negative, then theta is obtuse, which is in the second quadrant. That theta lies in the second quadrant, that is in between 90 degree and 180 degree. And finally, if theta is 90 degree, we see what is A dot B? Mod A mod B cos 90. You know cos 90 is 0. Therefore, A dot B is 0. It means A dot B 0. It implies that A is perpendicular to vector B. That is, A and B are perpendicular. That is the inference we get that if theta is 90. Okay? See, from the property 3, the third case, the property 3, third case is A dot B is 0. In this case, we have derived 3 inferences. A dot B, if A dot B equal to 0, we have 3 inferences, 3 ideas we get. That is, if A dot B equal to 0, first one, mod A is 0. That means A vector is 0 vector and B is any vector. A is a 0 vector and B is any vector. A is a 0 vector and B is any vector. This is one case. See, the A dot B 0 implies that if A is a 0 vector and B is any vector, or mod B 0. A dot B 0, either A is 0, B is any vector, or B is 0, A is any vector. In this case, B vector is 0 and A is any vector. Third case, A dot B is 0 implies A vector is perpendicular to B vector. That means if A dot B equal to 0, if and only if A vector is perpendicular to B vector. That means if A dot B equal to 0, if A vector is perpendicular to B vector, or if A vector is perpendicular to B vector, then A dot B is 0. This is if and only, two-way imply. If A dot B is 0, then A is perpendicular to B. Or if A dot A is perpendicular to B, then A dot B is 0. Two-way imply for this property. Okay. Next property, fourth one, dot product of equal vectors. Dot product of equal vectors. That is A dot A. This is equal to, mod of A and again mod of A, because B is equal to A. A dot A is mod A into mod A equal vector. Angle between the single vector A is 0. Cos 0. So mod of A, mod A into mod A is mod A square into cos 0 is 1. Therefore, this is mod A square. A dot A is equal to mod A square, or this mod A square is simply expressed as A square. So, if the dot product of equal vectors A dot A equal to mod A vector square or A square. This is another idea of equal vectors. Okay. Now, with this done, then I am completing this video here and we will continue the topic in the next video. Thank you.